And welcome. Thank you for listening to my final project looking at nested machine learning for predicting long donor utilization using Amazon Web Services, S3, Lambda, and SageMaker. So first off, what we need to do is go to S3. I've already created the buckets just because I've always had a hard time deleting them totally afterwards. But our initial bucket is going to be our initial data set. And as you can see, we don't have anything currently in our data set. And so we need to upload that. So we're just going to click the upload button, add our files. Here we go, and there we go. This is our data set, potential donors. It is HIPAA compliant, nonphysio.org. And once that's uploaded, we can see that we actually have it. And we can also download it if we need to, but we've already taken a look at it. So next up, we're going to be using Lambda. And so we go over to Lambda, and we have to create our function. And we're going to name it Slit Palm Transplant. And essentially, this is going to do two main things. First, we need to separate out our patients by adults and pediatrics. And secondly, we want to create two new data sets and place them in two new buckets. For some reason, I had to choose Python 1.1, and we'll kind of talk about that later. All right, so we're creating our function, and that also reminds me, we have to quickly go back. And so and we have to make sure that our other two buckets are there. I know they already are, but just to show you, since we're splitting them both into adults and pediatric pulmonary transplant patients, I have a palm transplant for the adult patients. I see there's no data in here yet. And then P for pediatric pulmonary transplant patients, and as you see, there's no data here. And so here we go. And so we can see we have our Lambda function here. It doesn't do anything yet. And we have some handy dandy code already set to go. And of course, I use Python for all of my stuff. And so this does a couple different things. This will split the patients into adult and pediatrics by less than 18 and then 18 years and greater for them. We're going to add a layer. And essentially, because we have to, where is it? Here we go. So we need pandas. So we just have to add a layer. Version 24 is the only one you can. You can do custom layers and stuff, but they already have it, and it's really difficult to add. We just click the Add button, and then as you can see, we have our layer added to our Lambda function. We're going to deploy it. And then we should be able to check it out. All right. Test it. All right. All right, and it did not work. Most notably because we have probably not created a IAM role for this. So we go down to our permissions, then we go over to config. Which we didn't actually add any actual permissions, and so we need to go down to permissions, configuration. We need to edit, And first off, we need to increase our memory because it's a very, very large database. We need to increase our timeout. And then we need to click on this down here to add an actual role. We need to add permissions. Attach, oh, sorry. Create an inline policy. A JSON. Add it. Next. Get a policy name. Split. Poem. Create the policy. We have it. Okay. Now, hopefully that should fix. Let's see. 3008 is the highest we can go for this. And then we should be able to go back and test it out again. Alright, so it looks like everything was successfully completed this time. We're going to go back to our buckets. Here's our adults. And we have a palm transplant for our adult patients. And then we should have a pea palm for our pediatric transplants. And so it's effectively separated them into two new data sets by age cutoff, below 18 and 18 and greater. And then we can go to SageMaker to work on machine learning. Now, the first time you get started, there's a button to essentially do some initial stuff, and it really takes like 10-15 minutes when you first do it. And so you get a screen like this. You can build notebooks, discover models over here, and they have some pre-done models which you can play around with, take a look at what you want to. It's a lot like Kaggle. You can take a look at some files, some tables if you have, look at samples, look at your data. You can do connections and catalogs, all of which we won't need to do. And so we go to notebooks, and you want to create a new notebook. And it brings you something akin to Google Colab or a Jupyter Notebook. And so if you're familiar with any of those, they should be fairly simple. Now, the one thing which I did notice is standard is 2 CPU with 4 gigs, which for this data set is not enough. And I found that by trial and error. And so what you want to do is you want to go to this button right here. And this is like your instance. But you can definitely change your instance. And when I did it before, the 2 times this 8 CPU with 32 gigs was enough. It has an idle timeout, and then you apply, and then you let it go. Alright, now that that's done, we can actually put in our code to take a look at our data. And I already have some handy dandy code through a lot of trial and error. It's very similar to any type of notebook, as I said before. And essentially what this does is we're building a machine learning pipeline. And this is a little bit different pipeline. Alright, so initially you have to do some of the initial importing of all of your different basics like OS and logging, all of your sklearn for the different pipelines. And so we're using Boto3, Pandas, NumPy, Matplotlib, all the standard stuff scikit-learn for a lot of our machine learning. And we're going to be doing something a little bit different called nested learning, and we're going to be using random forest as our machine learning, our supervised machine learning. And then we have to import all of our metrics to take a look at it with our confusion matrix, our PC curves, as well as our ROC curves, calibration curves. And then what we want to do is define them from our S3 buckets. And that's why we do the Boto3 before. And we have our bucket, and then we put our key, which in the key is really just the data set inside of your bucket. And then, of course, we have to deal with data leakage. And so we want to remove everything that can be highly correlated, such as, just for example, if you're going to transmit someone, you have to procure it, and so you can get a perfect correlation, and that can cause a lot of data leakage. And of course, you want to remove some of the other stuff that can be similarly highly correlated as well. And so that's what this part is essentially dealing with. The other thing which we had to deal with, and this is not quite machine learning, just kind of showing you what you can do. We had to deal with some of the time reference stuff and transition them to from a string to float variables. And of course, we want to take a look at all the shapes. We want to drop the columns, all the raw columns, which is what we're kind of doing here. And then kind of going down, we're going to start analyzing some of these cohorts, looking at the numeric versus categorical variables. And that's essentially what this is up here. And then here is where we're starting our modeling for our machine learning. And of course, we're using a random forest classifier. Here we're looking at the predictions with some of our output figures. Looking at our precision recall and other stuff like that. That's in this section. And then we want to take a look at both. One, then the other. And then we want to take a look at both of them together to see if there's anything that's similar between the two. Then we want to take a look at those two cohorts. And that's what the section here is doing. And then look at the different importance variables, not variables, but predictors. And then we want to take a look at some of the correlations and cross tabulations. And that's what we're kind of doing in this spot. So essentially you can do pretty much just about anything in this SageMaker that you could with any type of notebook or IDE, etc. And so the biggest part that's going to be different is where you get your data. And like I said, when you get it from a bucket, you have to import the botto and then name your buckets. And then what you can do is you can hit just the run all, and then we'll see how this goes. And you can see your usage down here. This does your CPU usage, your memory usage, and this gives you how much you have free. And then you kind of see what it's doing here. And then you just kind of wait for it to finish. Of course, just comparing, I've used Spider, I've used Jupyter Notebook, I've used Google Colab, and of course now I've used SageMaker. This has some definite benefits as well as some drawbacks. And one of the biggest pluses is, of course, if it's using too much memory or need more compute power, you can easily just change that over here and not have to purchase anything new. You might have to pay a little bit more money using more resources, but overall it's really easy to change. The downside is it's just a little bit clunkier than a typical IDE. They had a lot of extra stuff up here which I had to get removed. And of course, learning how to draw it in from the S3 buckets, of course, was a little bit challenging at first. But overall, we kind of got through it. Always see if it's still running. Up here, you see it's using a lot of CPU, and so we can always increase that if we have to. But it should run just fine. As you can see, we get some RC curves here, which is really good. The PR curve is okay, not great. Calibration curve is pretty good. Here's a confused matrix. And of course, down here, it outputs our top 20 features and their index level. The other thing which I like is they do put like the different graphs in here. You can take a look at them a little bit. You can change it to ascending, descending, You can freeze the panes, wrap the text, etc., and filter it out a little bit better. Here's our pediatric cohort. Here's our adult cohort. I should have said that before. And this looked at essentially 128,500 patients. And this looked at threefolds of the different candidates. And then down here you have the pediatrics, just shy of 5,000 total potential donors, I should say. So we got a pretty good RC curve here, a little bit better precision recall. Calibration curve was a little bit more, it's pretty good, except for this little dip here, up to about here, and then we kind of lost a little bit, and then cohesion matrix was pretty decent as well. And of course we have our top 20 features for pediatrics here. Here's the top 30 predictors across both adults and pediatrics. And then we can look at feature imports in adults and pediatrics. Here and then here is our analysis for our correlations. And this is what, again, not really strong correlations here, not really strong. Age right here is our strongest correlation here. And of course, we can take a look at the cross tabulations here. Nothing too exciting. Here should be our referral years. And here's we get into our pediatric patients down here. And then we can take a look at that, and we've got our years. And so just kind of so on and so forth. And so, like I said, I really like the notion you can change your instance really quickly. You can change things. You get more memory, get more CPU. But I said it's a little bit more clunky, and I think the best way to use this, rather than using a Lambda function and stuff like that, is really just create an S3 bucket and then do any splits instead of creating this Lambda function, which really took a lot of time and effort to figure out how it would run. To split our data was just to kind of split it locally and then upload it to the S3 buckets, so you didn't have to add layers. I think the Lambda function would have worked a little bit better if you wanted it a bit more automated. So if you're constantly uploading more data, and then you could run it, and more data, and you could run it, and you didn't have to continue doing it. But there we are. Hope you enjoyed the presentation. Overall, it was an eye-opening experience. And thank you for watching.